Hello all, welcome to the class. In today's class, we are moving on to logical implications. Let us see the definition of the logical implication. If P and Q are any arbitrary statements such that P conditional Q is a tautology, then we say that P is logically implies Q and it is denoted with implies symbol. P logically implies Q means P conditional Q is tautology. The second statement means P biconditional is tautology. We take an example. Mysore city is in Karnataka. So that is my P. Q is Mysore city is in India. That is Q. So here P conditional Q is true statement, tautology. Tautology means true. Therefore, you can say P conditional or logically implies Q. Logical implication makes use of rules of inference with an argument. General form of the argument is denoted with this notation. It's a valid statement. We have to prove that it's a valid statement. This P1 to Pn are called as hypothesis. These are all called premises also, and of the argument. Premises are always true and Q is a conclusion. If this is true, if we are able to prove this is true, then it's a valid argument. We will see the example. P is Ram studies, Q is Ram plays rocket ball, R is Ram passes discrete mathematics. Now P1 is premises that we are creating by all these combinations of these proportions. If Ram studies, then he will pass discrete mathematics. So how do you represent it in terms of symbol? Because you have if then, I have to make use of the keyword conditional. So Ram studies is a P conditional, he will pass in discrete mathematics is R, P conditional R. Second premises looks like this. If Ram does not play racquetball, that is negation Q. Because you have if then, I will use conditional again. He will study. That is P. Sorry. The last one is Ram failed discrete mathematics. Ram pass in discrete mathematics is R, then negation R becomes he fails in discrete mathematics. These are the three proportions that we have considered. So how do I write argument? P1 and P2 and P3. Those are all my premises. Conditional conclusion Q. So here is a valid statement. How do we do that? We just simplify all this together to obtain Q. So this is my argument. Consider all P1, P2, P3. You have to conclude Q. Q is Ram plays racquetball. So how do you simplify this? By making use of a truth table, you can conclude that it's true. Okay, so it's a valid argument. But when it comes to rules of inference, we will not solve this by truth table. We make use of a rules of inference laws. These are all the laws used in the rules of inference. First one is called as rule of conjunctive simplification. Second one is rule of disjunctive amplification. Law of syllogism is third law, and so on. we make use of all this to solve the problems.